Alright, I think we are live. Yeah. Welcome on in, everyone. I'm Robert, the AP Math Guy, and tonight we're going to be learning how to sketch the graph of our derivative functions. But we're only going to be given the graph of the original function. What's wrong, Lime? Everything okay? I'm so bad at that's okay, Lime. That's perfectly fine. I'll be honest with you. I can't draw to save my life, so um all I ask is that you try your best. That is all I ask here. Thank you, Lime. Thank you so much for that. So yeah, I'm gonna spend the next couple minutes clicking on the button that waves at different people, but in case I can't click on that button for you, I'm gonna go ahead and wave to you physically. Hi everyone. Also, as you're joining in, please feel free to do hit that like button. Hey Grandes, how's it going? How's it going? Hopefully everyone's Wednesdays went pretty well. What am I going over today? Today we're talking about how to sketch the graph of the first derivative, given only the graph of f of x. Are you teaching Calc 1? I am indeed, Alex. Although we are coming close to the end of Calc 1. Yeah. I'm going to go ahead and have a quick drink of water as well. There we go. Cool. Wow, GG, I'm barely kidding. That's okay. That is perfectly fine, Alex. I have the luxury of I have the luxury of doing this every day, so I'm gonna be a little ahead, but that's okay. That just means that when you do get to this, you'll already know how to do it, so you'll have a leg up on everyone else. How are you running class? Term length or semester long? I'm just going over different topics that I feel like are important. I'm just going over different topics. Favorite TikTok streamer, which I thank you. Just thought. Thank you so much. I really appreciate that. Really do appreciate that. God, it seems to be very similar to my 8-week Calc 1 class. Yeah, probably. Um, the difference is I'm not going to test you on this. Oops, I just dropped my pen. There we go, I got it. Can't can't work without a pen, right? Or any writing utensil. Thank you, Goat, for sharing the live. So today I have to give you a warning, everyone, and that is I can't draw. But some of you already knew that. Um, some of you who have been here a while already know that I can't draw. But I apologize in advance for the drawings that I'm going to attempt to do. So, yeah. All right. So, let's get this show on the road. All right. Can I graph the following? I don't know if you're sending me a graph or if you're giving me a function. But anyway, while that's going on, yeah, let's go ahead and talk about how to sketch the graph of f prime of x. So tonight, we're actually not going to be using, actually, what do I mean I'm not going to use this pad? I probably will use this pad. So let's say I have a function. I'm going to attempt to draw one. Let's say I have this function. And I'm asked to draw the derivative of this function given only this graph. I don't know what the function is, so I can't take the derivative. All I'm given is that this is the graph. What type of notebook do I use? So this is just a sketchbook I bought at Staples. Just a simple sketchbook. So I'm going to go ahead and create a little table of knowledge for us to be able to graph the derivative of this. So I'm going to note some key things. So what do I want to know? So, maybe I should have thought a little bit more about how I want to organize this table. You know what? We'll make it work. So, yeah, we'll make it work. So, what do I want to know? Well, the first derivative is going to tell me the slope of a function. So if my slope is positive, so positive slope means that on the graph of f of x, on the graph of f prime, it's going to be positive. Yeah, I probably should have thought about this a little bit more. Negative slope means the graph of f prime is going to be negative. Get the derivative? Well, we don't know what this function is. All I know is the graph of this function, and I'm going to be asked to find the graph of the derivative. When you mean positive, do you mean above the x-axis or concave up? That is a good question. So, excuse me. So here, because I'm dealing with the graph of f prime, so when I try to draw this positive just means above the x-axis, whereas this negative is going to be below the x-axis. And then at a max or min, that's where my zero is going to be. So like here, I have 3 zeros. Here, here, and here. On f of x, these tell me the roots of the function, or where f of x is equal to 0. On the graph of f prime, my roots are going to tell me where my maxes and mins are. So we know, remember, it's a max if it goes from positive to negative, and a min if it goes from negative to positive. What are we trying to find here? What are the instructions? So we're trying to find the graph of f prime given the graph of f of x. And that's what we're going to be doing all night tonight. And then I'm also looking for points of inflection. Points of inflection. On the graph of f prime, it looks like we have a point of inflection right here, because we changed from concave up to concave down. So this is going to act as a max or min on the graph of f prime. So it's going to be a max if I go from concave down, concave up to concave down, and a min if I go from concave down to concave up. So, using these 4 points, let's attempt to draw this. So, I'm going to go ahead and I wish I had a little more space, but that's okay. We'll make it work. Actually, let me zoom out a little bit. There we go. There's our space. So I'm going to attempt to draw the graph of f prime. So what do I know? I know. Thank you, Ranosh, for the follow. Hey, Imperfect, how's it going? So I know that right here is a maximum. So I'm going to line that up about there. I'm going to say it's about here. My min down here, which means that should be on the x-axis. Point of inflection, remember it's a max if I go from concave up to concave down, and a minimum if I go from concave down to concave up. So here, remember concavity is determined not only by a second derivative, but if we have a graph of x, we can look and see which way a function is facing. So from negative infinity to this point, which is 0, you can see that it's facing down. And then from 0 on, you see it's facing up. So because my slope is positive from here to here, my derivative is going to be above the x-axis. So I'm going to have something like this going on. Because remember, even though I'm heading in the negative direction, remember we read graphs from left to right. So here, I'm traveling up the mountain, so my derivative is going to be positive. Now from here to here, it's going to be negative, but I have a point of inflection here. So that means it's going to do something like this. And then I'm descending from this point to that point. So that's why on the graph of f prime, I'm below the x-axis. And then from here, once I get to my max, or once I get to my minimum, I'm going straight up. So, and that is the graph of f prime of x. Thank you Thank you, Ameli Gutierrez, for the follow. I'm doing okay and perfect. The derivative integral relationship finally clicked for me in physics. That's awesome! That's really cool. Is this Calc 1? It is indeed. It is indeed Calc 1. But yeah, so this, actually, this is the derivative of graph of that function. And all I needed to know were these four things. Can you do it one more time? No problem. We're going to be doing a few of these tonight. So don't worry. I just learned how to find critical points and mean value theorem. Awesome, Shant. That's really cool. That is really awesome. So yeah, let's try another one. So I'm gonna find. I want to use. Let's use this as our derivative. So this is the graph of f of x. I want to find the graph of f prime of x. So here, what am I looking for? First, I want to know where my slope is positive. So let's assume for a moment that here is my critical point. Here's my max or min. I'm going to draw my horizontal tangent line here at what appears to be x equals 0. Is that a maximum or a minimum? Thank you, Tom, for the follow. Chant says minimum. Lime says minimum. Yeah, what if I told you that you're both right? You're both absolutely right. Why? Because I go from slope down to my critical point and then back up. So whenever I go from a negative to positive slope, it's always a minimum. Very good. Very good indeed. Absolutely, Tom. Thank you so much for that. So, speaking of that, I know that this is a minimum. So, I know from negative infinity all the way to 0, my graph is going to be negative. So let's write that. So, f prime of x is less than 0 at the interval from negative infinity to 0. And then it's positive everywhere else. So my slope is increasing, or my slope is positive from 0 to infinity. What math is this? This is calculus. This is calculus. And all we're doing right now is we're just looking at slopes. And now, this is a minimum. So that tells me from negative infinity to 0, my function is going to be negative. So the graph of the derivative is going to be below the x-axis. And then here it's going to be positive, so it's going to be above the x-axis. And then since we only have one critical point at 0, so at f prime of x is going to equal 0 at x equals 0. So this is going to be a root. So this is going to be a root. And I'm putting in quotations because our roots are actually when f of x is equal to 0, but our derivative is going to equal 0 at that point. Thank you, Shant, for the follow. And now we want to look at our points of inflection. So points of inflection are when the second derivative is equal to 0. Now, if we look at this function, it's always going to be concave up. Why? Because the function is facing up. You can see that here. So there's going to be no point of inflection. Thank you, Hunter, for the follow. So no point of inflection. Point of inflection. So that means that on the graph of the first derivative, there's going to be no maximums or no minimums. So let's take a look at what that would look like. So following that, this is an approximate graph of what this would look like. So here, I have a root at x equals 0, so that's going to be here. Right, the origin. F prime of x is less than 0, so that means that anywhere from here on that way, my slope's going to be negative. Then here, my slope is positive. And there's no point of inflection, so there's not going to be a max or min. That is a line. And that is the graph of the first derivative. Yeah, I don't know too many babies that are doing calculus. If that's the case, then that's really impressive. Thank you, Fooled You Two, for the follow. So yeah, that's all we need to graph the first derivative. Any questions so far? Any questions so far? Is that line called tangential? This one? Nope. Nope, this is not the tangent line. So the tangent line tells us the slope of this function at any given point. Whereas the first derivative, this is essentially our slope graph. Thank you, Anonymous, for the follow. So this tells us what our slope is relative to each point. So like here, if we look at the function, I might have my tangent line as 0. If I pick a point anywhere to the left, let's say here, my slope, and I think I'm going to need my ruler for this. There we go. So I'm going to attempt to draw this. And as I stated earlier, I can't draw. So here goes nothing. Okay, that's not horrible. So here, the slope is negative. And then somewhere like here, the slope of the tangent line is going to be not that extreme. Is going to be positive. I do teach differential equations, and no, I'm not answering that question for you. So what I'm doing is essentially I'm taking all the slopes of all my tangent lines and putting them into one function or into one graph. So yeah. I'm not sure if you genuinely want to know that or if you're just trying to troll. Wait, can I get some help with graphing exponential lines? So exponentials aren't a line. It's a curve. Okay, if it's a genuine question, I'll be can answer that for you. For me, the hardest part um of differential equations was Laplace transforms. Just because it's okay, this means this, but that means that. At least that was the case for me. I hated those. Yeah. So right now I plan on getting the differential equation sometime probably around the spring of next year. At least that's the plan. Again, don't quote me on that because um it's always subject to change. I'm like week 5 in my differential. Okay, yeah. So you're gonna get to that around the end of differential equations. With like you'll probably get into there about a month to go. Yeah, I haven't done physics in years. All right. So any questions about graphing derivative functions? As you can see, last night where we graphed the original function given our function, it took us about an hour just to graph one of them. Whereas with this, we don't need as many things. So now, let's go ahead and turn the page. Thank you, Jake, for the follow. Let's go ahead and turn the page. All right, so let's try another one. Am I an actual professor or am I a student tutoring? Neither. I'm a professional tutor. I was a teacher at one point, but I left the classroom about 8 years ago. There we go. All right. So, I need to refocus my camera, so that's going to take a moment. There we go. There's my phone. All right. So now, let's try another one of these. Actually, nope. I'm going to move on to my graph paper for this one. Moving into the graph paper. All right. So it's going to take me a couple moments to draw this. So while I'm doing that, let's see if we can't get to 3K likes. Halfway's about there. Oh, perfect. We're already there. All right. So -1, -2, -3, -4, 1, 2, 3, 4. Hey, Math Tutor, how's it going? I'm glad to hear that. I'm really glad to hear that. All right. So let's do this. So let me go ahead. I'm going to try and draw this the best I can. There we go. All right. Thank you, Math Tutor, for the heart me. All right. So now here is the graph of f of x. I don't know what that function is, but I'm asked on the same coordinate plane to draw the derivative, the graph of f prime. So, what are some things that we notice? Well, first, let's ask ourselves, do I have any roots? Do I have any places where we cross the x-axis? Yeah, that's exactly right, Blue. Where is it? Yeah, right here. Cross the x-axis here. Nope, we don't cross the x-axis at 1. Okay. Wait a minute. Interesting. Yeah. So, now, let's take a look at where do I have any maximums or minimums? Blue says yes. Lalo says yes. Noel says yes. Imperfect says yeah. Yeah, that's exactly right. So where is what x value is my maximum on? Almost, Blue. Remember, when we look at max or min, we're looking at the x value. Yeah. So I have a minimum here at x equals a -2. And again, like I said, I can't draw, so we'll assume that that's the case. So here's my minimum. So minimum at x equals 2. At x equals -2, excuse me. That's right, Blue. That is exactly right. My max is at x equals 0. So maximum at x equals 0. Thank you, Spooks, for sharing the live. So now what else do we know? Well, we know that since this is a minimum, f prime of x is less than 0 on two intervals. Would it be relative? Yep, that's right. It would be relative max. That would be absolutely right. So my derivative is less than 0 where? It looks like I'm decreasing from negative infinity to negative 2. So negative infinity to negative 2. But it also looks like I'm decreasing from 0 to infinity. So I have to include that. So I add this u for union, 0 to infinity. And then it looks like, because this is a max, it goes from increasing to decreasing. So so my derivative is positive, is greater than 0 on the interval from negative 2 to 0. And now, is there going to be a point of inflection? That's right, Blue. Where is the point of inflection? I tried to draw it as specific. Yeah, I tried to draw it here. Right. So point of inflection. Point of inflection. At x equals negative 1. So remember what a point of inflection is. A point of inflection is where concavity goes from positive to negative or from negative to positive. And remember, concavity is just which way the function is facing. So here, the function is facing up. Function is facing up. And then here, the function starts facing down. So now, so here at x equals negative 1, am I going to have a maximum or a minimum on the derivative graph? Concavity goes from positive to negative. So what would that be? Close. A minimum would be from no, you're, yeah, it would be a max, right? Because if I'm climbing up and then I climb down. So now we have everything I need to draw this function. And I'm going to use a different color. So here, I have a minimum at x equals 2. And I have a max at 0. So that means that those are going to be my roots, or my zeros for the derivative graph. And here we go. Slope is negative here from, so slope is negative from negative infinity to 2. So I'm going to draw my slope being negative. And then from negative 2 to 0, my slope is positive. So I'm going to go above here. But I have a max at x equals negative 1. So it's going to be something like this. And then again, my slope is negative from 0 to infinity. So my derivative graph is gonna look something like that. So that is f prime of x. This is for calculus. This is calc 1. So yeah. Again, like I said before, I can't draw. So I'm sure someone could come up with a better drawing than that, but that's just my attempt at drawing it. Thank you, Blue. Thank you, Blue Raspberry, for that. Although I think I disagree. Thank you, Kamar Richards, for the follow. So, can I go over the inflection point again? Sure. So, inflection point. So, if we look at the graph, we're looking at. So, inflection point happens where the second derivative is equal to 0. So, the second derivative is where our function, or so second derivative, it shows concavity. So concavity is basically, okay, which way is the function facing? So if I just have a graph, I'm looking for where I'm switching from concave up to concave down, or vice versa. So here, if we look, the function is facing up, facing up, facing up, facing up, and then as soon as I hit this point, my function all of a sudden starts to turn face downwards. Thank you for the follow. I think that's a pink square. Is this one with vertex as well? So a vertex of the derivative would be here. But yeah. I have a feeling this one's going to be a relatively quicker live tonight. I only have a couple more examples to go, and then we will call it a day. So, see. Oh, that one looks fun. Here we go. Why does this keep being a little blurry? Huh. So, let's ramp up the difficulty a wee bit, but nothing I don't think you can't handle. Actually, I'm going to make my graph a little smaller so that way I can fit 2 of them onto this page. There we go. And I think the middle is going to be about that line. Yeah, about that line. There we go. It's going to be 1, 2, 3, -1, -2, -3. So, this will be 1, 2, 3. This will be -1, -2, -3. Alright, so here, thank you, Harry, for the follow. What are we learning today? So we are talking about how to sketch the graph of a derivative given only the graph of a function. So So here is our next example. So this is the graph of f of x. And I'm asked to graph the derivative function. I know some of those words in a picture is for awesome. So this is not a very good drawing, but here goes nothing. So what do we see? Actually, let me zoom in. Other than a horrible drawing of a function. Actually, I probably could have drawn that bottom part a little bit better. Oh well. So what do we see here? That we haven't seen before. There are asymptotes. That's right, David. That's exactly right. There's an asymptote. There's a vertical asymptote here at x equals 2, even though I can't draw it to save my life. And also, there's a horizontal asymptote here at the x-axis, on the x-axis. So how am I going to draw its derivative? Well, let's take a look at the slopes. So, as I go from left to right, which way is my slope facing? Or which way is my function going? Is it going up, or is it going positive or negative? That could be the function, Nathan. And it probably is. Nathan says negative, Ari says negative. Yeah, so my slope is negative here. And then what about from 2 to infinity? Is the slope positive or negative? Almost imperfect. Remember, we read graphs from left to right. That's right, Ari. It's negative. Why? Because as I'm going toward positive infinity, I'm sliding down. So, we know that f prime of x is going to be less than 0 on the intervals from negative infinity to 2 and from 2 to infinity. But I can't include 2. Why? Why can't I include 2? It's the vertical asymptote. That's right, Nathan. That is exactly right. So when I draw the function of a derivative, I still have to obey that vertical asymptote. You're right. It's not differentiable at 2 because it's not continuous at 2. And in order for us to have differentiability, there has to be continuity. And even then, it's not necessarily differentiable, but if it's not continuous, it's automatically not differentiable. So, we are going to put not differentiable at x equals 2. Also, we don't have any points of inflection either. How do I know that? How do I know that we don't have any points of inflection? What do you think? The end behavior is consistent. Yep. But I also know I don't have a point of inflection because there's no point where I go from positive to negative concavity or vice versa. I'm sorry, that's partially true. What I meant to say is there's no point where when I go from negative to positive concavity, the concavity is 0. So we know that this does not have a point of inflection. No point of inflection. And I don't remember if someone mentioned this already, but there's a horizontal asymptote at y equals 0. At y equals 0. If someone did mention it, I missed it, I apologize. So let's attempt to draw this function, this derivative. So here, if I draw the graph, and I'm going to do the best I can with drawing this because, as I keep saying, I can't draw. I think that's the middle. So here's going to be 2. So remember, I'm going to draw, to remember where my vertical asymptote is, I'm going to draw a dotted line here. This is just going to help me remember where my vertical asymptote is. So, here goes nothing. So here, we agreed earlier that the derivative is going to be negative along both of those intervals. So, I'm going to draw a negative, all my slopes. And because 2 is a vertical asymptote and it's negative everywhere, the slope is negative everywhere else, there's going to be no max or mins. So let's go ahead and try and draw this. So I have that going on, and I have this going on. And again, that's my best attempt at drawing this derivative. I'm sure there are people who can draw it a lot better than I can, but this is the derivative of f prime. Any questions on that one? That one was a little interesting, but it was still solvable nonetheless. So any questions at all? I don't see any, but if you're still typing, go for it. There's a vertical asymptote at -2. The limit is -infinity. Yep. Not necessarily. So when we talk about limits, we're looking at the original function. So here, the limit as x approaches 2 from the left is -infinity, but the limit as we approach from the right is +infinity, so the limit would not exist. Now, if this were our original function, then you'd be correct. Because as I get closer and closer to 2 from both the left and the right, it would tend towards negative infinity. Now, some people say that anytime you have a situation like this, the limit would not exist. I'm of the opinion that the limit does exist at negative infinity. Although some teachers teach that the limit does not exist there, and some do. I'm one of those that teach that it does exist at that point. Even though it would, even though yeah, no problem. No problem at all. Alright, so with that, I think it's time for the final problem. So, there are 11 of us in here right now. Let's see. To get to the final problem, let's try to get to 4.5k likes. Hey Patricio, how's it going? How is it going? Right, so yeah. Oh wow. Maybe I underestimated you all. Maybe I should have said 5k for the final problem. That was actually a lot faster than I thought. But good for you all. So, this one's going to be a little bit of a fun one. So, I probably should have started drawing while you were getting to the light goal. Let me draw now. I just realized there are two. I know this is going to sound silly, but there are two sides to the ruler. And for a while, I've only been using this side, forgetting about this side. Right. I also need to adjust my camera. So that's straight. There we go. Move you up here. So tomorrow, we're going to be doing one of our final topics in Calc 1, which is optimization. I plan on spending at least 2 lives on that one. There we go. Alright, so I'm going to let that be -2, -4, -6, -8, 2, 4, 6, 8, and 2, 4, 6, 8, 10, and -2, -4, -6, -8, and -10. Okay. So, here we go. And again, I'm going to do my best to draw this, but thank you, Lika, for the follow. That out a little bit. There we go. All right, we're gonna pretend that that's not a We're gonna pretend that that's not a spike. We're gonna pretend that that's a So slope, or pretend that yeah. I'm not drawing a spike there. Also, I am not getting into politics. It's not the place for it. I try to draw it smooth. Yeah, no problem, XR. Like I said, this is I'm not gonna get into politics because that's not this isn't this isn't the place. Anyway, so this is the graph of f of x. F of x. We want to know what is the graph of f prime of x. So, what do we want to know? Well, first, I don't know how to graph derivatives and tell double derivatives. Well, Latrell, you came to the right place because we're graphing derivatives tonight. So here, thank you, Latrell, for the follow. So, what is, excuse me. Actually, let me take a quick sip of water. There we go. So, there is an intercept here at 0, 0. Yep. What else do we see? What are some other points of interest? There is a minimum. Where is that minimum in perfect? Thank you, Tim, for the follow. Goes at -8. Yeah, so remember when we're talking about maxes or minimums, we care only about the x values. Yeah, so the max is here at 6, at -6, x equals -6. Hey, Brandsy, how's it going? And where is a minimum? Or at least my best attempt to draw a minimum. That's the y value. What's the x value? So if here, that's right, slowly descending. That's right, Latrell. It is. So look at the x value, and we see that it's at x equals 4. So let's write those down. So we have max at x equals -6, and a minimum at x equals 4. What else do we see? What are some other things that we see? We've got some points of interest. What can you tell me about the slopes? What can you tell me about the slopes? Not much today. I learned a very important topic, and that is partial. That's cool. That's really cool, Brandsy. That is really awesome. Well, that's just my attempted drawing of it. But what can you tell me? Can you tell me anything about where where my slopes are increasing or decreasing? The flat spots are at the exact points of the intervals. Well, the interval. Hmm. Maybe I asked it in. Maybe I asked. Maybe I worded it a little bit Maybe I worded my question a little bit improper. Let's try again. Not necessarily, because here I'm above the x-axis, but my slope is decreasing. That's not necessarily true, Braden. Let me try asking this a different way. On what interval does my slope increase, or intervals does my slope increase? On what? Well, this arrow. What does that arrowhead tell us? Yeah, that's right. So when you see an arrow, it means it's when you see an arrowhead, it means it's continuing forever in that direction. Like here, it's going to negative infinity, and here it's going to positive infinity. That's exactly right, Krispy Kreme. So my derivative, so the slope, or f prime of x, is greater than 0 on the intervals from negative infinity to negative 6 and from 4 to infinity. Yeah, sorry about that. Let me try and zoom out a little bit more. Well, for some reason, my camera isn't cooperating tonight. Do you see it now slowly descending? Is that better? Yeah, no problem. Okay, so as you can see, when there are these arrowheads, it means it's going forever in that direction. So the slope is increasing from negative infinity to negative 6, right? Because remember, we read graphs from left to right. And then from here, from 4 to infinity, it's also increasing. Where is the slope decreasing? Or let me ask that a better way. Where is the slope negative? On what interval? On what interval is my slope negative? Negative 6 to 4. That's right. So on the closed interval, open interval from negative 6 to 4. So now we said earlier that there's a max at x equals 6 and a minimum at x equals 4. Or, yeah, maximum at x equals negative 6. I don't remember if I said negative or not. All right. Is there a point of inflection? In other words, is there an x value where our concavity goes from facing up to facing down, or from facing down to facing up? That's right, Latrell. That's exactly right. Here, at x equals 0, the function goes from facing down, because this is a downward facing parabola, to up, because that's an upward facing parabola. So point of inflection at x equals 0. So is that point of inflection going to be a maximum or a minimum? Remember, we go from negative to positive, so it would be a on the f on the derivative. That's right, slowly descending. That's right, oh wait, no. Yeah, that's right, slowly descending. It would be a minimum because I'm going from negative to positive. That's right, Mark. Yeah, no. Don't be sorry, Miguel. Please don't be sorry. Do not be sorry at all. I'll be honest with you, I make a lot of mistakes too, so don't worry about it. Just know if I went from positive to negative, then it would be a max. You know a lot about math, right? I don't know a lot about it, but I know what I know. But there's no one who knows a lot about math because math tends to be once you leave like algebra and calculus and stuff, it branches out everywhere. Thank you, Zephyria Crown, for the follow. Alright, so now I have everything I need to attempt to graph the derivative. So remember, whenever the derivative is greater than 0, it's going to be above the x-axis on the derivative graph. And whenever it's less than 0, it's going to be below the x-axis. When it's 0, it's going to be a root. And the point of inflection is going to be where we switch from, is going to be our critical point on the first derivative graph. So let's go ahead and try and draw this. I don't understand the point of inflection at 0. Okay, so I'm going to go ahead and draw this first, and then I will answer that question. So, from negative infinity to negative 6, our slope is positive. So I'm going to draw my point here and here. Why? Because those are my critical points. Derivative is greater than 0 on that interval, so we're going to have something like this going on. And then we know that from negative 6 to 4, our derivative is going to be negative, so it's going to be below the x-axis. But there's going to be a point of inflection at 0, which is a minimum. So it's going to be something like this. So that is the graph of f prime of x. Thank you, NPIR, for the follow. Okay, so let's talk about that point of inflection. Why is this a point of inflection? It's a point of inflection because points of inflection tell us where the concavity changes signs. So concavity, I can't zoom out much more than this. I have a document camera into this as far as I can zoom out. I have a document camera and it doesn't have the function where I can press a button and zoom in or out. Instead, in order to zoom in or out, I have to physically move it. But yeah, so back to points of inflection. So here, we know, so points of inflection exist where concavity changes signs. So all concavity is just simply which way the function is facing. So here, this is a downward facing parabola. So the function is facing downward. So it's going to face downward. And then here, I have an upward facing parabola, so my function is facing upward. So at some point, there has to be a point where the if I go from a negative concavity, which means I'm facing down, to a positive concavity, which means I'm facing up, then at some point, there has to be a point where the concavity is 0, and that would be right there. Because here, we switch from from a negative concavity to a positive concavity. Thank you, Seventh Wonder of the World, for sharing the live, and thank you, Bobby, for the follow, which gives us an intercept, right? Not always. Not always, but on the first derivative graph, it will always give us either a max or min. Like here are my roots for the first derivative, and the second derivative is the derivative of the derivative, so we're looking for where the derivative is 0. Sometimes it's an intercept, though. Like here, it was an intercept, but not always. Does that answer your question, Steve? Hope that answers your question. So, with that, I'm going to go ahead and call it a night. But before I do, I have some things that I need to show you. So, here it is. Yes, but I got lost on the derivative. Okay. So, derivative tells the story of the slope, right? So, the derivative tells us the slope of the tangent line at any given point on the function. So, like here, let me use a different pen. So, like here, I go from positive to negative slope. So if I draw the tangent line at that point, the slope at that point is going to be 0. Whereas if I draw it like right here, it would look something like that. And somewhere like here, it would look something like this. And the tangent line is going to closely emulate the function. Not exactly emulate it, but closely. Hypothetically, can another function have points of inflection at -2 on the x-axis of the graph? Yep. Absolutely. Yeah, no problem. All right, so back to what I was talking about. So I download all my lives as soon as they're done, and I upload them here onto this channel when you get onto this channel. So anytime you miss a live, it'll always be here. I like to say it's going to be within an hour or two of the live finishing, but sometimes that doesn't happen. But it'll be up the day at the latest the day after the live. So once you're here are here's the set of all the things you should do when you get to that channel. And then, if you want to follow me on TikTok, you can follow me at Robert the AP Math Guy. So, right now, I think as of now, I'm not sure if I have 2,100 followers or not. I think I do. I was pretty close entering tonight. So, yeah. Can I ask how you got the curve by -4 and 2? Are you talking about the derivative, or are you talking about the actual function? Because we're talking about the actual function that was given. Oh, are you talking about these ones at the ends? Okay, so we know that the first derivative of f is positive on those two intervals. So whenever we're drawing the derivative, our function, so whenever we're drawing the graph of the derivative, if the slope is positive, it's going to be above the x-axis. Kind of like if I had, like here, if I picked a random point on this function, on this original function, like here, how do I know it's positive? Well, I know it's positive x because it's above the x-axis. The derivative works the same way. And then as far as the as far as the shape of those, um, well, I don't actually know. That's my best drawing of it. I'm not sure if that's going to be the actual case. So anyway, and then there are a couple other people that I recommend that you follow as well. So starting with ACG Math Tutoring. So she's really good at getting people ready for the ASVAB, the Accuplacer, the GED, the TEAS test, as well as giving people just a reminder of algebra and geometry. And in fact, if it weren't for Audrey with ACG Math Tutoring, I wouldn't even be on TikTok to begin with. So she's she definitely deserves a follow. And then also, I recommend that you follow Learning with Lynette as well. So she is really good at teaching the abacus. In fact, I think she is live right now. Let me quickly check. Yep, she is. So, as soon as we are done here, I'm going to go ahead and jump into that live. And if you want to join me, feel free to do so and tell her I said hi. Or tell her I sent you. And then, let me turn the page. I also offer online math tutoring. So I offer group tutoring and I also offer one-on-one tutoring as well. So for group tutoring, I offer it to groups of 3 to 10 students per group who are all taking the same class at the same time. So that doesn't mean that you're taking it with the same teacher or even at the same school. You just have to be taking the same class. And here is a list of every subject that I actively tutor. And so for group tutoring, for the 2025-26 school year, I'm only charging $35 per hour per person. I also charge and that's for group tutoring. I also do one-on-one tutoring as well. My rates for that depend on how often you need tutoring, how often you want to meet per week. So, um, if you're interested in either one of those, feel free to DM me here on TikTok to schedule your free consultation. Or if you're seeing this on another app, feel free to comment down below and we will set up a consultation. All right. Hey man, can you please cover the circle in radians? My teacher covered it too quickly. Are you talking about the unit circle? All right. So, I did I do a live on that? I don't think so. I'll have to check. If I did, you'll be able to find it here. But I'm not sure if I did that one or not. If I didn't, I'll add that to the list, and I'll do it probably sometime before I get too far into Calc 2. All right, one more question. What is the definition of a derivative in this graph in double derivative? So derivative tells a story of the slope. So the derivative tells me the slope of the tangent line at any particular point on the function. So that's the definition of derivative. There's also this thing called the limit definition of the derivative, which is this. So limit as h approaches 0 of f of x plus h minus f of x all over h. But we are letting h, so if I pick a random point and then I add h to that point, so let's say this is my f of x, no, x f of x. This is x f of x. I pick a different point, like say here, and this would be my f of x plus 8. No, why do I keep getting that backwards? X plus h, comma f of x plus h. So to find the derivative, I'm essentially letting these 2 points get closer and closer together until they become essentially 1 point. But they can never be 1 point, otherwise it's division by 0, which isn't allowed. So that's how the derivative would work. And then double derivative. What is the double derivative? Do you mean the second derivative? Because I'm not sure I've ever heard double derivative before. But let me quickly take a look. Maybe I'm thinking that that is the second derivative. Yeah, so it's the second derivative. Okay, so the second derivative is the derivative of my derivative. So we can take derivative on top of derivative on top of derivative until one of two things happen. Either A, the derivative is 0, or B, the derivative is no longer defined. So the second derivative so first derivative tells us slope, second derivative tells us concavity. So the first derivative tells us the slope at a point. Second derivative tells us which way the function is facing at that point. So yeah, so that would be the meaning of the derivative and second derivative. So yeah, so tomorrow we're going to be covering concavity. No, not concavity. Tomorrow we're going to be talking about optimization. And I think that is the last topic that we're going to get into in Calc 1. Because after that, I'm going to take the weekend to do some algebra topics. Oh, speaking of which, there's one more thing. I am going to be starting to do a second live starting on Monday. And so, I'm going to have my first live at 2 p.m. Eastern, and that's going to cover everything before calculus. So, no, I'm not talking about like, okay, what number comes after 6? Nope. So, anything from algebra on to pre-calculus. I might include stats on that as well. And then the second live is going to happen at 10 p.m. Eastern, and that's going to continue with calculus and beyond. So that starts on Monday. Until then, I go live every day at 11:30 p.m. Eastern. So from tonight until Sunday night will be the last night that I go live at 11:30 p.m. After that, I will be live at both of these times. So yeah. With that, we'll go ahead and call it a night. Have a great rest of your evening, everyone, and I will see you tomorrow at 11:30. Bye, everyone.